Okay, so this is our class matrix once again, except now we have three new error handling classes objects that are able to handle error of invalid dimension, index out of bounds and incompatible matrix. So there's a driver that will test all of this, and we have the HPP that will implement all of this. Right. So for invalid dimension, just now as I mentioned, it's just yeah. If someone gives you a -1 to construct your matrix, it wouldn't make sense. You cannot construct a matrix you cannot construct a matrix out of -1 row and negative 1 column. Right. I mean, and then for index out of bounds, right? That's index out of bounds is where you're trying to access a row or column that is more than what you try to implement for, even though our aim is 3 3. Try to access 4, right, over here. This out of bounds. Right. And then for the last one is our incompatible matrix. This is called when you're trying to scale, when you're trying to add, subtract, or multiply, add, subtract, or multiply two matrices with each other. So if you try to add a matrix of M3 3 with M 4 3, when you're adding matrix, right, we didn't really go, I mean, maybe you did went through matrix before, but if the rows and columns don't match up, right, you're not able to do it. This will result, this is what is meant by incompatible. Right, they're not meant for each other, just like Romeo and Juliet. So we can go through how I implement it. For invalid dimension, let's see where it's called. Wait, it's called so many things. Alright, it's called here. So when you construct HLP object, so for this one, right, since we are, our original way of constructing was to put everything outside, right, using these two, using this what's it, operator. But now since we cannot construct without knowing whether its dimension is valid or not, we have to put them inside. And then we check first. If r is less than 0, or if column is less than 0, we will throw the invalid dimension error. Then we throw this error, right, it will go into here. You will receive it here. You will store it here. And then it will construct a message based on the error. Right? So this error will be constructed when what is called. Yeah, when what is called. So here this function is in the driver file. You will try to do this. Then some text this is text incompatible. Okay. Here, invalid dimension. You will try to do this. And then you're trying to create a matrix of row -2. So there'll be an error. Right? So this function, so you will call, you try to construct an error. The error constructor will be called, the normal constructor will be called, you will detect that r is less than 0, you will throw this, and then this try function, this try block will catch the error. It detects an error of std exception. And then you will print out the what function. So when what is called, right, we will run this function, invalid dimension. So it will print out the error message based on what? Is it because of rows? Is it because of columns? Or is it because of both row and column? So you have to write it out. Then since this is all strings, right, you need to convert the data that you got before to strings. Right, std to string. So that they do magic. Just use what is provided by the compiler, by the C++ library. And this function, right, is standard. This, I mean, you can try to remember, but this is what we will always do for constructing messages. Virtual const car star function. So this is a return type. This is the function, and then you const everything inside. Because yeah, and then you have a static message. It's the same for this. How you construct error message. It's just how it's supposed to do. So that's for invalid dimension. Now for index out of bounds. So the index out of bounds. Okay, if your rows is 2 and columns is 2, right? And when you try to construct it, when you try to access rows of 2, it will fail. Why will it fail? Because of how we count in programming, right? In programming, we don't count. Okay, let's say we create a m of rows and columns, and then our row equals to 2, our column equals to 2 as well. Okay, make it simple. So if you construct this, right, you get a row of 2, 0, 1. This is 2, right? Column of 2, 0, 1. So you see the error that will occur when you try to access m column. So what you're doing here, right, is that you are trying to get m of, you're not getting, you're trying to get the second, trying to get this. It's out of bounds. Doesn't make sense, right? Because of the way we count in programming, where we start from 0 instead of 1. So when we have 2 columns, right, you have they're indexed by 0 and 1. They're not indexed by 1 and 2. When you try to access row 2, it doesn't exist. So it's an error. It's out of bounds. If you don't have the error code, right, you will get a segmentation flaw. Right. These we are all very familiar with. Traumatic memories. So yeah. So we'll create an error function that handles that. Right over here. No. Sorry. And that's out of bounds. Yes. Right over here. So nothing much to say. They will try to access row, and then we'll say invalid. That's for rows. Now, you guys will be wondering, why don't we do it for columns as well? Why we only do it for rows, right? If we remember how we do our bracket operator moves, how we do our bracket operator over here. This part, we are doing it like this, right? Oh shit. Yeah, okay, sorry. Was not showing. We're doing it like this, right? Where we have the matrix here. Return a vector. Right, our operator is like this. We have the matrix return the index of a vector. And then see, the compiler will handle it. Will handle and give us the value. So how will we know that column is invalid if we are letting the compiler handle this part? Right? We're not doing this part, we're only doing for rows. So that's why for this exercise, we can only detect mistakes that happen in rows. If you want to do, if we want to handle mistakes for happening in columns, right? We will have to create another object, not a vector, but another object, and then we return that object, and then this object will detect the error itself, which is more work, but it is necessary work. But for now, we can only detect row, we cannot detect column. Why we cannot detect column is because when it's caught within the bracket operator, we have no way of knowing what is caught within here. This is blind to us, right? In our code, we are not able to see this, so we are not able to tell whether column is invalid. We are only able to tell whether row is invalid. So yeah. Then now for incompatible matrix. Oh, this one need to write a lot. This one you can go through by yourself later. But basically, this one, if what would throw this error, right? Let's go. Okay. So for every operator now, you have to create this incompatible matrix error. So it's supposed to be a single line, but it's a bit too long. So I create 2 lines for it. If the columns of left hand side doesn't match with the columns with the rows of right hand side, you'll throw this error. Same thing as I mentioned over here. Yeah, they're incompatible. When incompatible, you throw the operation that throw it, and then you throw all the rows and columns. Yeah, just give it all the values. Multiplication, subtraction, and that's it. This one, right? This is scaling. Scaling uh is with a scalar. It's not with a matrix. So we won't run the problem with incompatible matrix. Yeah. So that's it. Three operators, classes. They are wrap up. Yeah, they can print their own error message. You can study how to do this. You should study how to do this. And then yeah, try it by yourself so that you can learn. And that's about it. That is the end of the session today.